So far, we've been working with equations that have radicals in them, but they've all been square roots. And we know that sometimes we can use indexes which are greater than 2. What do I mean by the index? I mean this number. So that implies it's a square root. But we can also work with 3s and 4s. So we're going to do a couple here where we look at solving equations that have an index greater than 2. So let's solve the fourth root of u is equal to 3. Fourth root of u is equal to 3. So just like we did when we had square roots, we need to cancel out the radical. Well, it's not a square root anymore. It's a fourth root. The index is 4. So we'll use the same number as our exponent, right? That's the power that's going to cancel out the index in the radical. So this 4 cancels out this one. We have to do the same thing on the other side. So 4 cancels out 4, and we're left with u. U is equal to, now we do 3 to the 4th power, which is 81. And then, of course, we always want to check these, right? So we would substitute 81 back in here. We would take the fourth root of 81 and confirm that, yes, that is in fact 3. So we have a nice solution here. We could see the cube root, so maybe we'll do a 3 here, of x is equal to, we could do, let's try negative 2. So your first thought might be, hey, we can't take roots and get a negative. You can't take even roots and get a negative, but you can take odd roots. So let's try to clear off this radical with a exponent of 3 on both sides. So this will cancel out that. We will be left with x equals, and then negative 2 to the 3rd power is negative 8. And we, of course, want to check it. So the cube root of negative 8 is equal to negative 2. What is the cube root of negative 8? Yeah, it is negative 2. This is a case where it's okay to have negative numbers. That checks out, so we have a solution. Let's try one more. What if we have the fourth root of 9w minus 9 followed by plus 3 equals 0? So this is, again, one of those cases that we have seen before where you have your radical and then another thing, another term, another number on the same side of the equal sign. You can't do anything as far as getting rid of or clearing away that radical until you isolate it, right? We have to take this and isolate it first. We have to isolate that first. That means getting rid of this plus 3. So let's minus 3 from both sides. Minus 3 minus 3. We now have the fourth root of 9w minus 9 equals, this is gone, so we have our equal sign, negative 3. Now here's where you might be thinking, wait a second. Can I do this negative? Can this be negative? If it's an even root, then no, you can't. This is going to be one that has no real solutions, but we'll continue just to confirm that. If we did apply an exponent of 4 here and here, what would happen? Well, this one would clear out the radical, leaving us with 9w minus 9 equals negative 3 to the 4th power is 81. We would add 9 to both sides to get 9w equals 90. And then we would divide by 9 to get w equals 10. We always want to check these, so we would go back to the beginning, take our fourth root of 9 times 10 minus 9, because we would substitute in our w for 10 for w, plus 3 is equal to 0. We would work out what's inside the radical, which is 90 minus 9 then plus 3 equals 0. We would do 90 minus 9 to get 81. We would take the fourth root of 81, which is 3, and then we would add 3 and say 6. And we see that 6 does not equal 0, which means there is no real number solution here. So indexes that are greater than 2 work the same way as all the square roots that we have seen. We just have to use a different exponent to clear those radicals.